elementary school. Let me back up. We're doing the review for nonparametric inference. We're doing question 6. It's the Wilcox Signed-Rank Test. And what they're doing is the reading comprehension strategies employed by good and average elementary school readers. Each group is evaluated on how often its members employ each of the 8 different strategies. They're doing this factor specificity score, and the researchers conducted a Wilcoxian signed-rank test to compare the score distributions of the good and average readers. Now, I don't know why they did this signed-rank test, because that would be with paired data, and I don't know how they paired the good and average readers, but that's how they're doing it, okay? So, for this particular problem, obviously compare is going to be shifted to the left or the right. It's going to be the not equal to, and the null is always going to be identical. All right, and so I have the data here, and so what I'm going to do is I'm going to put this data into RStudio, and we're going to calculate the difference in RStudio. We're going to get the absolute difference, and then we're going to rank it, and I'm going to talk about what to do about these scores here. And then we're actually going to get the test statistic. And then we're actually going to compare the rejection region with the table. But we're going to do the test to determine whether we're going to reject or not reject and get the p-value. Switch over to RStudio. All right. So here is what I did in RStudio. I created reader data, okay, and I put it in a data frame. I want to put it in a data frame so that I can calculate the difference, the absolute value, and then the ranking. It's much easier to do this in a data frame. So I'm going to title my first variable good, obviously, and I put in all of the good scores. I have the comma, and then I did shift enter so that I can put in the average, and then put in all of the scores for that average, and then I'm closing out my data frame. So now I have a data frame called reader data with 2 variables, one called good and one called average. Now what I'm going to do is I'm going to do reader data $. So I'm going to be adding difference to my reader data, and I'm going to define that variable difference as reader data $good. So it's going to call all the good data minus reader data $average. So it's going to subtract 44 from 30, and that's where the 0.14 is going to come from. Okay, so this line right here is creating this difference column. All right, now I want to take the absolute value, so reader data $ is going to add a variable. The variable I want to add is absval. Again, I don't like calling variables by function names because I think it can potentially confuse the computer. Now, the absolute value function in R is ABS, and then open, and then I'm going to do reader data, and then I'm going to tell it to look in the different variable, okay? So it's actually going to take 14, and it's going to take its absolute value. It's going to take -7 and make it its absolute value of 7, all right? And so all of these are here. Okay, so now that I have that done, once I've gotten rid of all of the positives and negatives, I'm going to be able to actually rank these. Now, I'm going to do reader data $rank, okay? Probably should have done rankings, but I did rank. The reason I don't like that is because rank is the actual function. Now, I do the ranking of the abs value, okay? And I got 6321758. Now, in ranking, you can determine the ties method of average, and I have seen it do 2.5, 2.5, right? Because these are actually tied, and you should get 2.5 and 2.5 here. The default method for the random method where whereas the default average replaces them by their mean. I do not know why it is not replacing them by the means here. I have seen it do 2.5, 2.5, but the only place here in my test, right, it does want the 2.5 and the 2.5, and so I do need to recognize that these are tied, and I need to take the average of 2 and 3, which would be the 2.5. Now, for the actual test statistic, it doesn't actually matter. I create T negative, and all I do is I go, all right, here's a negative score, that's 3. Here's a negative score, that's 2. Here's a negative score, that's 1. Here's a negative score, that's 4. So there are 4 negative scores, 3 plus 2 plus 1 plus 4. And I don't even have to worry about that, right? Because what's the average of 3 plus 2, right? It's 5 divided by 2, 2.5, right? So the sum here is still 5. And you can see T negative shows up here as 10. And then my T positive is the 6, the 7, the 5, and the 8. So the 6, 7, the 5, and the 8. And I can see that that's 26. So my T negative and my T positive are 10 and 26. Now, so T is going to be 10. The reason I use T is because it shifted left or right. So if I go to my thing here and I look, it says shifted left or right. I do just T, and it's the smaller of T positive or T negative. So that's why I chose T, right? Because it's a two-tailed test, and I chose 10 because it's the smaller. Now I do need to find the rejection region using the 5% level of significance. I do have 8 data values. You can see 8 observations. So I don't even have to do the length function, right? So I have 8 observations of 5 variables. So my N is 8. And so I'm going to back up. And here, two-tailed test, alpha is 5. I go to 8. I have 4. Okay, is my rejection region, so 4. Now it's like, if T is less than 4, is that the rejection region? Yes, if T is less than 4, that's the rejection region. 10 is not less than 4, so I do not reject. Okay, I do not reject here. And then, of course, if I wanted to find out what the p-value was, I could just do the Wilcox test. I can compare reader data good to reader data average. And then I want to make sure that paired is true because this is the signed test. And I do get 0.3125. Now, what I will say is if you do this in StatCrunch, you do get a slightly different number. It's 29 instead of 31, but still super duper close. And both of those are rejection regions, right? And so that is how you would do the Wilcoxian signed rank test in RStudio.